Hello, welcome to all in my YouTube channel, all about civil engineering. I am Praveen Mane. At the start of video, you have seen what contents I am sharing through this channel. So please share the channel links and also watch the videos carefully, and also you subscribe the channel so that it will give me motivation to prepare such more fruitful videos. Already I have started the video lectures on engineering mechanics. Today I am giving lecture on rectilinear motion of particle. We have studied different terminology in engineering mechanics. What is meant by engineering mechanics? What are their different branches of engineering mechanics? And what is meant by different terminology like particle, free body diagram, body, mass, different quantities involved, different terms involved, that is velocity, acceleration, different properties of the material, that is the displacement, distance, and whether these quantities are vector or scalar. What is meant by scalar, what is meant by vector, that we have studied already. What is meant by force, it's studied in unit number 1. So here I am giving a lecture on rectilinear motion of particle. Rectilinear motion means inline motion, in straight line, motion of particle in straight line. As motion is involved, so this topic is related with the dynamics. It is the one of the branch of engineering mechanics. And then after theoretical part, I will give you solution of some numericals also, step by step solution of numerical. So we'll go for the session. Now, what is meant by rectilinear motion? Before that, we study the basics. We memorize these basics. So first is the dynamics. It is the part of mechanics which deals with the analysis of particles or bodies which are in motion due to application of force. So when there is an involvement of motion of anything, any body or particle, we should have their cause of motion. So there are two sub branches of dynamics, that is the kinematics and kinetics. So kinematics, it is the study of relation of displacement, velocity and acceleration with respect to time for given motion without considering the forces which causes the motion. So here in this kinematics, we'll study such objects or such particles which are in motion, rectilinear motion, but we are not considering the cause of motion, that is the force. And then kinetics is the vice versa of kinematics. Here study whatever study, that is finding out relation between displacement, velocity, acceleration with respect to time for given motion with considering the cause of motion, that is the forces acting on it. It is the kinetics. So now rectilinear motion. When particle moves through space, it describes a curve which is known as a path. When path is a straight line, then the path is said to be a rectilinear motion. Particle is nothing but this is a point mass. It is the negligible mass. It is a thing which is having negligible mass. So particle. So already I have you have two terms, that is distance and displacement. So here, so if this is point A, this is point A and this is point B. If suppose particle A, particle X, consider particle X which started its motion from this point, O point. He travelled 10 meter up to the A. Then again he travelled to up to point B 15 meter. So distance is equal to the whatever distance travelled is 10 plus 15 is equal to 25, and displacement is nothing but it is the movement, or it is the exact accurate distance between starting point and end point, that is the OB, that is the distance OB is called as the displacement. So it is 10 minus 15 is equal to minus 5. Why it is 10 minus 5? Because in the reverse direction. If it is in reverse direction, that's why it is -5. So arrow is be showing like this. There will be sign convention. The part with the right is positive, left arrow towards left is negative, arrow towards upward is positive, arrow towards downward is negative. Now equations. There are different equations of rectilinear, equations of motion. Equations of motion. Here x is equal to s is equal to displacement, as you already learned what is meant by displacement. Then velocity is equal to rate of change of displacement with respect to time, and acceleration is rate of change of velocity with respect to time. So these are the this is the definitions of displacement, velocity, and acceleration. Already you have studied. This equations also you have already studied, but we just revise it. So as you know, acceleration is equal to rate of change of velocity with respect to time, that is dv by dt, which we written as dv by dx into dx by dt. So the dv by dx is the velocity. Dx by dt is the velocity, that is the ds, x or s, dx by dt or ds by dt, it is the velocity. V dv by dx, it is the acceleration. It is the equation. Acceleration is equal to v into dv by dx. So here we will integrate this and we'll get the following equations. First equation of motion is equal to v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus twice as. So here this v is equal to final velocity of particle, this small u is equal to initial velocity of particle, s is the displacement, and a is the acceleration, and t is the time. Now we'll go for different motions. First, motion under gravity. The motion under gravity means, so as you know, if we throw any object upward, after some time, after traveling some vertical distance, it will come back. Without any force, it will come back. So that motion is called as the gravity, or gravitational force is acting on that particle or on that object. So the motion of particle under the action of gravitational force is known as motion under gravity. So there are different characteristics. Throughout motion of particle, the gravitational acceleration is always in the downward direction. So gravitational acceleration g is equal to minus 9.81 meter per second square. At the maximum height, velocity must be 0. If velocity will be 0, then only the object will come downward. If it has some velocity, it will go upward. And then third is the velocity of particle at any height must be same in magnitude in upward or downward direction. So these are equation. We change this equation, that is we put value of a as the gravitational acceleration, then we will get v is equal to u minus gt, ut minus half gt square, v square is equal to u square minus 2gs. That equation we need to use when we will analyze the numericals like motion under gravity. So these are the equations. But if motion under gravity means gravitational force, gravitational acceleration, we need to use gravitational acceleration value is minus 9.81 meter per second square. We will put this minus g. A is equal to minus g. We will get these equations. Then problems based on constant acceleration. Now acceleration is constant. So first we will solve this problem. Different types of constant acceleration, variable acceleration, that will solve. So numerical is a motorist is traveling at 72 km per hour along a straight road when he observed a traffic light 187.5 meter ahead of him turn red. The traffic light is timed to stay for 15 seconds. If motorist wishes to pass the light without stopping, just as the signal turn green, Determine first uniform acceleration, second velocity of the motorist as he passes the light, and third is the how long motorist will move with constant retardation. So we'll go. First we'll write, whenever you solve the problem, you first write given data. What is given data? Initial velocity is equal to 72 km per hour. We'll convert it into meter per second. So 72 into 1000 divided by 3600. It will be meter per second. This is the conversion of unit. In another video, I will show you how to convert these units. Then distance between motorist and light is equal to S is equal to 187.5 meter. Time required to pass the light T is equal to 15 seconds. So using equation of kinematics for constant acceleration, S is equal to ut plus half at square. So one will put the value and we'll get the acceleration value. Then B, V is equal to u plus at. We use the equation V is equal to u plus at. V is equal to 20 into 1 into 15. So we'll put this acceleration value here. So 5 meter per second. And now see, after passing the light, motorist is moving with initial velocity of 5 meter per second, and with constant retardation, its final velocity must be 0. So using equation V square is equal to u square plus twice S, V is final velocity is 0. So 5 square minus 2 into 1 into S. S is equal to 12.5. So that will be the answer. Now second, a sprinter runner in 100 meter race accelerates uniformly for first 35 seconds. Acceleration is constant, uniform. Then runs with constant velocity. If the sprinter time for the first 35 minutes is 5.4 seconds, determine his time for race. So initial velocity of sprinter is us is 0. Then sprinter traveled 35 meters in 5.4 seconds. Then traveled with constant velocity. Distance of race is 100 meters. So S is equal to ut plus half at square. This equation we'll use. So we'll put value. We'll get the acceleration value. That is a 2.4 meter per second square. Then maximum velocity attained by sprinter is given by V is equal to, maximum velocity is final velocity. So V is equal to u plus at. V is equal to u plus at, first basic equation. So here u is 0, and here we'll put the value of a, and t will get the maximum velocity or the final velocity attained by sprinter. Then now distance traveled by sprinter with constant velocity is given by x is equal to vt. Distance traveled by x is equal to how? Because velocity is equal to rate of change of distance with respect to time, displacement with respect to time. So v is equal to x by t, and here we rearrange the equation, x is equal to v into t. So here put value distance traveled by sprinter with constant velocity. So x is equal to 100 minus 35 is equal to 12.96 t. So t is equal to 5.02 second. So total time per race is equal to 5.4 plus 5.02 is equal to 10.42 second. So distance traveled by sprinter with constant velocity 100 minus 35. Total distance per race is 100. Without constant velocity, it traveled 35. So we get this distance. Then a bicycle starts from rest, and after traveling along a straight path, a distance of 20 meter reaches a speed of 30 km. Determine the constant acceleration and how long does it take to reach the speed of 30 km per hour. So here you solve this example and then check the answer of it. So now problems based on the motion under gravity. Earlier we have studied problem with normal motion. So positive direction motion. So it may be a horizontal motion. So under gravity, motion under gravity means the motion will be upward or downward. So it is downward only motion. So first we'll need to throw it, any object, upward. Then after becoming final zero velocity, it will come back to the earth. A ball is released from rest at a height of 12 meter at the same time that a second ball B is thrown upward 1.5 meter from the ground. If the balls pass one another at a height of 6 meter, determine the speed at which ball B was thrown upward. So here, firstly will throw the ball A for 12 meter. Then ball B is thrown upward 1.5 meter from the ground. So 1.5 meter from the ground. From here we thrown ball B. So both the ball passes each other at a distance of at a height of 6 meter. So this is the 6 meter. Ball B position is here, A position is here. So 6 meter. So determine the speed at which ball B is thrown. We need to find the speed of ball B thrown. So UA is equal to 0, height h is equal to 12 meter. UA initial velocity of A. The ball pass one another at height of 6 meter. Downward distance travelled by ball A is equal to 6 meter. Time required to travel a downward distance of 6 meter is given by S is equal to UT plus half GT square. So here we'll put value S is downward, that is minus 6, U is 0. So this will be 0, half into G into T square. So T will be 1.106 second. Then let UB be the initial velocity of ball B. Upward distance travelled by ball B is 6 minus 1.5 is equal to 4.5 meter in time T is equal to 1.106 second. S is equal to UT minus half GT square. In earlier equation, why I used a plus sign? Because the motion of the ball is upward. Here the motion of the ball is downward. So S is equal to 4.5, here UB into T minus half into G into T square. So here we'll put the values and we'll get the UB is equal to 9.49 meter per second. So we'll solve this equation. Then at T is equal to 0, second problem. At T is equal to 0, bullet A is fired vertically with an initial velocity of 450 meter per second when T is equal to 3 seconds. Bullet B is fired upward with velocity of 600 meter per second. Determine the time T after A is fired as to when bullet B passes bullet A. At what altitude does this occur? So UA initial velocity are given UA and UB. Let T be the time required for bullet B to pass bullet A. So vertical distance travelled by bullet B in time T is equal to S is equal to UT minus half GT square. So HB is equal to this. So HB is the S. There is travel distance, height. It is height. That's why I used here H instead of S. And it is the distance of travelled by B bullet. So that's why HB. So UT minus half GT square is equal to HB is equal to 600T minus half 9.81 into T square. So here we'll get the one equation, HB is equal to 600T minus 4.905 T square. So vertical distance travelled by bullet A in time T plus 3 seconds, because already bullet A we have fired and after 3-minute time passes, then we have fired bullet B. So time for bullet A will be T plus 3 seconds. So here same equation we are using, we will get the second equation. So we will solve these two equations, equation 1 and equation 2 mathematically. We will get T is equal to 7.28 seconds. At time T is equal to 7.20 seconds, bullet B passes the bullet A. Then maximum height attained by the bullet is given by S is equal to ut minus half gt square. So here t will we are putting u, we know that is the B. It's a 600 is the velocity of initial velocity of B bullet. So maximum height attained by the bullet B is given time is h is equal to 4.11 kilometer, that is 4108 meter. Then here the depth of well up to water surface is h meter. So here h meter. A stone is dropped into the well from the ground. After 3 seconds, the sound of splash is heard at the ground. If velocity of ground is 330 meter per second, find the value of h. Initial velocity of stone. Sorry, here I have written something wrong. Example. So here ground, not velocity of stone. Velocity of stone. Then initial velocity of stone is equal to u is equal to 0. Depth of well up to water surface is equal to h. Velocity of sound is equal to 330 meter per second. Sound. This is sound. Sorry, is here velocity of sound. Velocity of sound is equal to 330 meter per second. Let t be the time required to reach the stone or water surface. S is equal to ut minus half gt square minus h is equal to, because it is a vertical, 0 minus half into, we'll put the value, we'll get the h in terms of t. And 3 minus t be the time required to reach the sound of splash at the ground with constant velocity. And when velocity is constant, acceleration is 0. So s is equal to ut plus half gt, half at square. We'll put values, we'll get the second equation. Then we'll solve equation 1 and 2. We'll get the value of t as 2.87 seconds. Then from equation 1, we'll find the value of h. Then this is the another example. You solve it and then check your solution check your solution with given solution. So thank you for watching the video. If you like the video, please do share it and subscribe the channel for more such fruitful videos. So in the next video, we'll go for the curvilinear motion of particle. So thank you again. Please subscribe the channel for such fruitful videos.